we are going to prove the quadratic formula. So you remember this is the general form of quadratic equation, ax squared plus bx plus c equals 0. A, B, C represent those numbers that are multiplied by the unknowns, and C is just a lone number in that equation. Now the formula below, x equals minus b plus minus square root of b squared minus 4ac over 2a, that's how you find the answer to this equation. We want to know how we got that formula. Where does that formula come from? So we're going to start from the general form of quadratic equation and step by step actually obtain this quadratic formula, this famous formula. Let's get started. I'm going to write that one more time. Ax squared plus bx plus c equals 0. So how should we go about finding the answer when we're looking at the general quadratic equation in the general form? So we have these two unknowns here, one of them to the power of 2, one of them to the power of 1, and we have a lone number c over here. If I could write this down, write this equation in a way that I could like separate the unknown from the rest of the stuff. For example, I could say x plus something, and obviously it has to be to the power of 2 so we can generate this x squared, parenthesis x plus something to the power of 2, and then outside of the parenthesis I have some stuff based on ABC, some expression based on ABC, and then equals 0. So if I could change this general form into this format, then I can simply keep these parentheses on the left hand side, take whatever number I have to the right hand side, the expression based on ABC, and then take the square root of both sides. So I will have the answer. If I take the square root of that form, x plus something to the power of 2 becomes x plus something to the power of 1, and then that will equal plus minus of that expression based on a, b, c. So that's sort of the thinking that we do during proving the quadratic formula. And always with proving mathematical theorems or just proving formulas in math, it's kind of like try and error wrestling.
Wanna wrestle?
Paying attention to the clues. It's always like that. There's no one definite answer that you can just follow that script and you would be able to prove anything. It's back and forth. You try something, doesn't work, you come back, try something else. So it's a little bit like wrestling. Okay, let's now start with that strategy. How can I wrap the x inside the parenthesis? Let's first divide all sides by a so that we can get x alone. So dividing the entire equation by x, left and right, so it becomes x squared plus b over ax plus c over a, and then 0 divided by a is just 0. Now how can I wrap this guy into an expression that would look like x plus something to the power of 2? What would work? What this something would be to generate this after expansion? So this is where the unions become handy. Remember when we talked about the unions, for example, when you have a plus b to the power of 2 equals a squared plus 2ab plus b squared. So you have your first term squared, second term separately squared too, but then in the middle here you have a and b multiplied by each other and multiplied by 2, right? So can we use this union to figure that out? So can I say x plus b over a to the power of 2. Does that work? Well, according to the union, that will give me x squared plus 2 times x times b over a plus b over a squared. So 2 times x times b over a, that's just 2b over ax, which it doesn't look like what we have here. Doesn't look like b over a times x, it's double of that because of this 2 got multiplied by it. So let's try something else. How about I substitute in here, instead of b over a, I divide it by 2. I say b over 2a and then raise it to the power of 2. Let's see what happens. So in that way I get x squared plus 2 times x times b over 2a and then plus b over 2a to the power of 2. So now if you look at here, you get 2x times b over 2a. This 2 cancels with this 2 and you get just b over a times x, which is exactly what we have here. So this works, but you will get also this extra thing, this extra plus b over 2a squared. This is extra, but it's okay, we can subtract that since there's no unknown included. This in b over 2a squared, there's no unknown inside, so it's just we know ABC are numbers, so we can just subtract that again in the formula. What do I mean?
What do I mean? What do you mean? What do I mean?
Here's what I mean. The equation becomes x plus b over 2a to the power of 2. I know x plus b over 2a to the power of 2 will generate x squared plus b over ax. So far so good, that's what we wanted. But it also generates b over 2a squared, which is extra. This is not what we had in our first expression over here, right? So far we had this part, but we didn't have this part in the original equation. So what I do, I can subtract it. I can say x plus b over 2a squared minus b over 2a squared plus, and then I have this term, c over a, I include that, plus c over a equals 0. Now these two equations are equivalent. The extra b over 2a squared that this generates, we subtract from it. Now the benefit of this, writing the equation in this format, is what? The benefit is that now all the unknowns are in that parenthesis, which is raised to the power of 2. And now I can keep the unknown on the left hand side and take all the rest, which are just based on ABC, to the right hand side. So I just do that. X plus b over 2a squared. I keep that on the left hand side, take everything else to the right hand side, or like subtract both sides by CA and add both sides by b over 2a squared. So then it becomes b over 2a squared minus CA. Perfect. Now I just need to simplify the right hand side, write it as just one fraction, and then take square root of both sides. I'm going to, in the next step here, just simplify that fraction. So we have b over 2a squared, that's equivalent to b squared over 4a squared minus c over a. We need a common denominator. So 4a squared and a. 4a squared is the suitable common denominator. So 4a squared, we had b squared in the numerator, and then minus What will the second fraction become? That's what you have to do. A has become here the denominator 4a squared. It means it has been multiplied by 4a, right? To generate 4a squared from a, you have to multiply a by 4a. So we do the exact same thing to the c. We multiply c by 4a, which becomes 4ac. Does that sound familiar? Does that ring a bell? B squared minus 4ac? That's the discriminant. We're getting close to the answer. So what we have here is x plus b over 2a squared equals b squared minus 4ac over 4a squared. Now what I need to do, I take square root of both sides. So x plus b over 2a squared equals b squared minus 4ac over 4a squared. Taking square roots from both sides will give me, on the left hand side, just the power of 2 will be eliminated. So it becomes x plus b over 2a, just with no power, so we don't need to even write the parenthesis, equals, taking square roots, but also remembering that it will become plus minus square root of that. Why plus minus? Because if this right hand side, if it was negative and then you raise the negative to the power of 2, it becomes positive. So the negative of the right hand side, the negative of the square root of the right hand side will also be an answer. So that's why we include this plus minus here. Whenever you're taking square roots on both sides of the equation, one side becomes plus minus because negative times negative is positive. Square root or any root that is even, like 4th root, 6th root, 8th root, again the plus minus comes into the picture. Nice. So I take the square root, becomes b squared minus 4ac over 4a squared. Excellent. So this square root is taken from this entire fraction. So I can write it like separate from the top and bottom. Separately we take the square root. B squared minus 4ac, and also the bottom is square root of 4a squared. I can actually calculate 4a squared. I can simplify that because both of them are squares. Because 4 is 2 to the power of 2, then we have times a to the power of 2. So taking square root of this is both 2, the powers of 2 cancels. So this will end up as plus minus square root of b squared minus 4ac divided by 2a. Nice. So one more time, we get what? We got x plus b over 2a equals plus minus square root of b squared minus 4ac over 2a. Now what I need to do, I just need to subtract both sides by this guy to eliminate it from the left hand side. So I'm going to, in our last step, subtract both sides of the equation by b over 2a. So then I get x isolated on one side equals b, so minus, because we're subtracting, minus b over 2a plus minus square root of b squared minus 4ac over 2a. So because these fractions now are like fractions because they have the same denominator, I simply just add up the numerators on one fraction. So x equals one fraction, the denominator is 2a. On the top I have negative b plus minus square root of b squared minus 4ac. Nice. So in that way we got the formula. Hope you guys enjoyed it. Let me know what you think if you have any questions or suggestions for more videos. Thanks for watching.